Prime factorization. Factor trees. Before we get into prime factorization, there are two key ideas to review. First, that factors are the numbers you multiply together to get another number as the product. Second, a prime number has exactly two factors, 1 and itself. And since you've worked with prime numbers before, you should remember that the first few prime numbers are 2, 3, 5, 7, 11 and 13. Mathematicians call prime numbers the building blocks of all positive whole numbers because every whole number greater than 1 is either a prime number or a composite number. The word composite means made up of various parts. Each composite number is made up of a single set of prime factors. In other words, you can get to every composite number by multiplying a single set of prime numbers together. We call these the prime factors of a number. I'll show you how this idea stacks up for the numbers up to 15, prime numbers in red and composite numbers in blue. 2 is prime, 3 is prime, 4 comes from 2 times 2, 5 is prime. We get 6 from 2 times 3, 7 is prime. 8 comes from 2 times 2 times 2, 9 is from 3 times 3. We get 10 from 2 times 5, 11 is prime. 12 is from 2 times 2 times 3, 13 is prime. 14 is from 2 times 7, and we get 15 from 3 times 5. Prime factorization means finding that single set of prime numbers that multiply up to a given composite number. To do a prime factorization, we can use a factor tree to help us split each composite number apart into its prime factors. Let's do an example. 18. We split 18 into factors until we can't split any more. I am using red for prime numbers and blue for composite numbers. I say to myself, 18 comes from 2 times 9. I circle 2 as a prime number. I will come back to it later. 9 is a composite number, so I split it down. I get 9 from 3 times 3. 3 is a prime number, so I circle both of them too. I have no composite numbers left, so now I know I have found all the prime factors. Next to the factor tree, I restate the prime factors. 2 times 3 times 3 is 18. It's correct, but it's not quite finished. To do a really great job on prime factorization, we show a factor that is repeated by using exponents. We call it using exponential notation. It sounds fancy, but it's easy enough. Check it out. How many 3's have I got? 2. So I say 2 times 3 to the power 2, because 3 is used twice, is 18. It makes the final answer very tidy. Notice that I listed the prime factors from smallest to largest. That is the standard way of listing prime factors, and you should do that too. Here's something cool. It doesn't matter how you split your composite numbers down, you always come out with the same prime factors. I could have done it differently and said 18 is from 3 times 6. 6 is from 2 times 3. I still get the same prime factors of 2 times 3 times 3 or 2 times 3 to the power 2. Different way of getting there, but it's still the same result. One more example and then it's your turn. We will do the prime factorisation of 48. I know that 4 times 12 is 48. This time I have two composite numbers to work on, the 4 and the 12. 4 comes from 2 times 2. 2 is prime, so I circle them both and move on to the 12. 12 comes from 2 times 6, and 6 is from 2 times 3. I circle all the primes. No more composite numbers are left, so I'm ready. Next, we collect all the primes we circled. 2 times 2 times 2 times 2 times 3 is 48. And for a great final answer, we use our exponential notation to tidy up those repeated factors. 2 came up 4 times, so we say 2 to the power 4 times 3 is 48, and that's all you need to do. Now it's over to you. Have fun with prime factorisation.